So, Assalamu alaikum dear students, welcome back to Learn Daily Physics. So, in our previous lecture, we find out these equations. So, we see that these equations are the second order differential equation. So, and we know that for every second order differential equation, we have some answer, we have some equation which is satisfying that second order differential equation. We have a solution for that second order differential equation, we can say in a simple words. So to find out the solution for this equation, first we have to write a characteristic equation for this. So a characteristic equation, if you have studied the ordinary differential equation, so you know that what is a characteristic equation, ordinary or the partial differential equation, then you will be familiar to it. Characteristic equation, and it will be equals to I'm considering this equation, this one. So it will be equals to d square will be equals to minus omega c. This v of x will be cancelled out, and we write a characteristic equation like this, and d will be equals to, we know that d will be equals to plus minus iota omega c. It was square here, and it will be a square here, and it will be plus minus omega iota omega c. So for the every characteristic equation, we have an auxiliary equation for this characteristic equation, where we from which we find a solution. So if you want to learn how to make these characteristic equation, how to make these auxiliary equations, so you have to go back to the ordinary differential equation, and to the course of ordinary differential equation there are 8 equations, I think, characteristic equation. For the every characteristic equation we have an auxiliary equation, auxiliary solution equation. So you better go there and you have to check them, but it will be a more difficult thing for you, that you have to go back, you have to look for everything. So we will see everything which we need. So necessary things will be seen here. So v of the auxiliary equation. So let's go for the auxiliary equation of this characteristic equation. So auxiliary equation for this will be equals to that we are going to find out the v of x will be equal to alpha e power iota omega c t. Okay, and this is the solution equation. We can say that for this from this characteristic equation we write this value here, it will here, and alpha is a constant term here, and this is the auxiliary equation for this. Okay, so we can write this equation as equation number 5. So when we take we will find out the value of this alpha. This alpha is equals to v perpendicular. How this is equals to the v perpendicular, we will find out this alpha. What is this alpha? So before that we will take a derivative for this, and it will equals to vx of that, vx dot equals to alpha e power iota omega c t into iota omega c. Okay, so this is an equation for the vx dot, and in our previous equations we have find out a relationship for, you can find out that in my previous video. So this is, here it comes. So this is my previous equation for the vx dot, and it is equals to omega c v of y. And from equation number 1, where is equation number 1? This is, let's call this equation number 1. So from this we can find out the value of v of y. This v of y will be equals to and this v of y will be written here. If you can see here, right here. So this is equation 1, we say. So from equation 1, v of x dot equals to plus minus omega c v of y. This is equation 1. So v of y will be equals to 1 over plus minus omega c, divides here, goes here and divide, and v of x dot. Okay, you understand what I've done. From this equation, we've derived this equation in our previous lecture. So from this equation, we have derived this one, deduced this equation, and now we are going to put the value of this vx dot here, and let's see what happens. So when we put the value of this vx dot here, this value here, so we will get that v of y equals to 1 over plus minus omega c into iota omega c e power iota omega c square. Is omega c and t. It's omega c and t. Omega c and t. Let's find out. And we have alpha here. This omega c is cancelled out by this one, and we get that v of y equals to plus minus iota alpha e power iota omega c and t. Okay, omega c and t. So now we have find out the value of v of y. We have find out the value of v of x also. So let's move on. Let's calculate the value of this is the imaginary, we can say this is the imaginary value of v of x and v of y. Then how we have to find the value, we have to find the real values for this. Then how can we find the real values for the v of x? V of x equals to, we know v of x equals to alpha e power iota omega c t, and we know that e power theta equals to iota theta. If you say iota theta equals to cos of theta minus plus iota sine of theta. You cannot, if you want to put theta here and not. So e power iota theta is equals to cos of theta plus iota sine theta. So e power iota omega c t will be equals to alpha into cos of omega c t plus iota sine of omega c t. This is v of x. So this v of x is equals to, so if you multiply here, you can see that this is iota and this term is a imaginary term. This term is imaginary term, so we will neglect this imaginary term. So for the v of x, real v of x will be equals to alpha cos of omega c t. Okay, so the real value for will be equals to alpha cos of omega ct, and for the virtual one, you say v of y is equals to this term. So we will write that v of y from this equation, and write this equation, if we name this as equation number 6. So from equation 6, v of y equals to plus minus iota alpha e power iota omega c t. So we can write plus minus iota alpha into cos of omega c t plus iota sine of omega c t. This iota will get multiplied inside, and it will be equal to plus minus iota alpha cos of omega c t, and when this will be multiplied with this, it will be iota square, and iota square is equals to minus 1. This minus 1 will invert the sign, these signs, and it will become from plus minus, it will invert and it will become minus plus sine omega c t. Okay, so now this one here is the imaginary term and this one is the real term, so v of y real will be equals to minus plus sine omega c t. We will further, when we will draw the graph for these equation, then we will see that why we are having this minus and plus in omega ct in y, and this v of x is positive, it don't have any sign. We will see that when we will discuss the our graph, so here we find out these values. So let's calculate the value of alpha. For the value of alpha, so let's have a look that v of x equals to alpha cos omega c t from this equation. This is equals to dx by d of t equals to alpha cos omega c t. So if you integrate this, this dt goes here, and from an arbitrary origin x naught to x, where this is the arbitrary origin where the time equals to 0, and d of x, it will be equals to alpha 0 to t time t cos of omega c t, and this t comes here and it will equals to d of t. So if you integrate this, it will be equals to x minus x naught equals to alpha into sine omega c of t, alpha sine omega c of t, and this omega c will be, this is it's an angle and it will be divided here omega c. So we can say that from v of y also we can, if we solve this equation number a, right, this is equation number a, and when we solve this equation like this, when we integrate this equation like this one, we will get a solution like y minus y naught will be equals to plus minus alpha e power iota omega c t over iota omega c if you integrate this equation. Okay, so if you integrate this equation, you will get this answer, and if you will integrate this equation, you will get answer which I'm going to write now. It will be equals to plus minus alpha cos of, this integration for this equation will be equals to cos of omega c t over omega c. So we are going to write this as equation number b. This is the equation number a and this is the equation number b. So now what we have to do, we have to take the square of this equation and this equation, taking the square of equation number a and equation number b and adding them. What will happen that this will get positive one, get when we square the positive term, it is equals to the positive term, and when we square the negative term, it is also equal to the negative term. So this positive negative will be equal to the positive value. Okay, and it will be equals to alpha square cos square omega ct over omega c square, and it will also be equals to alpha square sine square omega ct. So let's taking square of equation a and b, taking the square of equation a and b, taking square of equation A and B. So it will be equals to x minus x naught whole square plus y minus y naught whole square equals to taking common alpha square over omega c square. If you want to write an equation, I'm making a shortcut. I'm taking a shortcut here. I'm missing one step here, so you can do that step. It's an easy step. I'm just taking a common from that. So sine square omega c t plus cos of square omega c t. Okay, so this term will be equals to, if you look on your right side, so if you have ever studied the equation of a circle, so x square plus y square is equals to r square. Okay, if you have studied circle, it will be like this, and the magnitude of x square plus y square equals to r square, and it will x square plus y square equals to r square. This is equation for a circle, and this is also an equation for a circle, but it have some arbitrary, we are minusing some arbitrary terms from this, some constant terms from here and here also, but it is overall an equation, circle equation. Okay, equation for a circle. So we can write this as r square equals to alpha square over omega c square. So our main goal or our main aim is to calculate this alpha, what this alpha is. So now comes the tricky thing. It's not that tricky, but you know that v is equals to r omega. When you talk about v is equals to r omega, the angular acceleration, angular velocity here. So omega is equals to v over r. So r here will be equals to v over omega. R square equals to v square over omega square. Okay, v is equals to r omega, r is equals to v over omega, and r square is equals to v square over omega square. So here from this term we can write that r square is equals to v square over omega square. If you write this equation, you name this equation, and you compare this equation with this equation, you can see that this alpha is equal to v. Okay, from this equation and this equation, these equations are same regarding of this alpha. Here we have alpha and here we have v, so this alpha is equals to v, and this alpha, from that we can say that alpha is equals to v perpendicular. Why we are using this v perpendicular? This is the velocity of that ion perpendicular to the magnetic field. So keep this term in your mind, that this is equals to v perpendicular, and this v perpendicular, and this will be also equal to r perpendicular, you can say. Okay, so r perpendicular will be equal to v perpendicular over omega c. Okay, so writing, if we have every alpha value, we can put this alpha in different equations where we have this alpha. So v of x will be equals to, if we put this alpha here, v of y is equals to plus minus, where is this v of y? This v of y was equals to plus minus, here we have an alpha sine of omega c t, and v of x is equals to alpha cos of, and we can put this value v of x here. So v of x will be equals to v perpendicular and cos of omega c t, cos of omega c t, and v of y will be equals to minus plus v perpendicular sine of omega c t. Okay, so now the last thing which we have to do is we have to make a graph for this. So we will make this graph in our next lecture. So we will discuss about that all these equations will be used in that graph, and we will see that what v perpendicular is, what is gyration, what is alarm of motion, and why we apply electric field or a magnetic field to the plasma, and it start to move in a helix motion. It starts to move in a motion of a helix, just like have you ever seen a DNA, a double helix? DNA is a double helix, and it's a single helix, and it moves like this, like a cyclotron we already discussed. So in our next lecture we will draw the graph for it from these equations. So I hope you've enjoyed it. So if you like the video, so please like the video and subscribe to my channel. And if you want notes about these courses, so we are providing the at our website www.learndailyphysics.com. So you may visit them, that website, and download our notes and books regarding to your courses. So assalamu alaikum, and thank you very much for your time.